Looks like we're live. Hello everyone and welcome to yet another recreational programming session with Mr. Azuzin. Let's make a little bit of announcement and officially start the stream. So a red circle live on Twitch. And what are we doing today on twitch.television website? Today we're doing something interesting. Today we're implementing React and Rust for terminals. I'm gonna give the link to twitch.tv/Toding and I'm gonna ping everyone who's interested in being pinged. So I'm gonna explain what all of that means in a second, right? So essentially today we continue working on for@, which is the chat system, right? I wouldn't say chat application, it's a chat system in Rust, right? So because it consists of the server and it consists of the client, so it's a client server and circus clown architecture, right? So it's a circus clown architecture. So and recently we developed a very simple client for this chat system. So we used to use just telnet for simplicity, but recently we implemented like an actual client using Crossterm, which is the Rust library for cross-platform terminal stuff, right? So let me actually demonstrate you. Yeah, let me actually demonstrate you. So what you're supposed to do, you're supposed to run the server first, right? So this is quite important. So let's actually do the server. Right, so let me actually grab the file path to the project so I can actually open that stuff in a separate terminal. Right, so and let me actually copy paste the token. So we're currently authorizing via the token that is generated by the server. Right, so it is generated by the server, so you basically give that token to the people you trust and they provide that token in a client when they are connecting. So that's kind of the point. Right, so let's actually start the client. So I'm going to do cargo run bin client, and here is the client. So it's, as you can see, it's a TUI application, text user interface application. So it has commands, right? So one of the commands that you're supposed to use connect command. You provide the IP, in our case it's a local IP, and then you provide the token. Right, so I don't have a token copy pasted anywhere, so I suppose what I need to do first, I need to add that token to the clipboard, right? So I'm going to do something like this. Right, I don't have an X clip. Or I'm sorry, I'm an idiot. So it's actually a token. So let's actually go to the client, right? So and essentially I'm gonna connect to 127.0.0.1 and I'm gonna just copy paste like that, and there we go. We finally connected, right? We finally connected. You're supposed to send messages, and as you can see, the server receives the messages. If you connect another client, you will be able to see the messages of other people and stuff like that. So this is basically the chat application, and it works great. It works great on, you know, real operating systems like Linux. Unfortunately, I've got some reports from the, you know, operating system for video games, right? So it's called something like Doors or Windows, right? So there is an operating system called, for gamers called Windows, and people reported that they have some sort of problems with this application, which is kind of expected, right? So this is not a video game, so obviously it is not going to work that well on an operating system for video games. So that was quite expected. So let's actually take a look at that. So somebody actually tweeted that at me. So let me see. So here is the tweet. It's going to be in the description, right? So unfortunately I can't access that tweet. Right, so it is straight up banned in my country because Twitter is a very dangerous website with propaganda. So I literally can't open that website, unfortunately. I can't open that website. But through the magic of VPN, I actually downloaded the video on that post. So we still can watch that, right? So I'm going to show you. So I think it's flickering. Yeah, flickering MP4. So here it is. So that's the video that was reported to me. So as you can see, this is the operating system for video games, right? So this is the terminal, obviously, for video games. Yeah, so when they open this application, it starts to flicker. So apparently the operating system for video games doesn't have enough FPS, which is quite surprising to me, right? So Like it's for video games, so like you're supposed to have a lot of FPS. So there's also another problem that some of the, I can't catch the moment, but sometimes the keys that you press are pressed twice. We already fixed that. That's a bug of Crossterm. So somebody submitted a pull request, I accepted that. So it's a known problem. But this is quite concerning. This is quite concerning. You know why? Because when I was implementing this client in one of the previous streams, I think I even said that out loud. I said that I think Crossterm actually implements buffering, right? Some sort of a buffering. And by buffering, I meant that it has this virtual terminal. It maintains that virtual terminal. Every changes you make to that virtual terminal. And then before flushing the state of the buffer, it would actually compute the diff between the frames and only apply the changes where they're needed. So, and I even compare that to a virtual DOM of React. Right, do you guys know about virtual DOM of React? It's kind of a similar concept, right? So basically React maintains its own like a virtual copy of the DOM of the browser. And instead of applying the changes to the real DOM right away, it basically accumulates the changes, finds the diff, and finds the way to sort of like apply only the things that changed, thus greatly, allegedly improving the performance. It's been proven several times, but that's not the case, but nobody fucking cares. I think it is the case for Facebook. Right, I think as far as I know, it is the case for Facebook because their website, the DOM of their website is so clusterfuck overcomplicated that they need these kind of solutions to actually improve the performance. So yeah, that actually supports the thesis that React was developed by Facebook for themselves, not for you, right? If you think Facebook develops React for you, you're completely wrong. They develop in React for themselves. So anyway, and essentially what we're going to be doing today, we're going to be implementing virtual DOM in Rust for terminal. Because apparently Crossterm doesn't support that. I looked around, I googled around, and apparently Crossterm is considered the low-level library. It is a low-level library, and because of that, it's not a concern of such a low-level library. It's for the high-level peasants to think about that buffering. So, and because of that, we are the peasants who's going to be implemented that freaking buffering. So luckily, it's not that difficult. You literally just maintain a 2D array, and instead of rendering directly into the terminal, you render into that 2D array, and then you just find the difference. Luckily, it's not a tree, it's not a DOM. Finding the difference between two-dimensional arrays is super easy. And then basically we can form some sort of a patch, and we can apply that patch through the Crossterm commands, if that makes any sense. I think it would make more sense when we actually start writing the code. Right, so I think that's a pretty interesting topic. So yeah. All right, let's go ahead and do that. So I think I need to close everything in here. It should be pretty straightforward. I hope so, at least. So I'm gonna go into the client, and so as of right now, we're sort of like maintaining immediate UI style, rendering. So for instance, I have a client and I have a chat, and it has a method to render, right? So, and essentially in that method to render, right, we provide the queuable command, basically the terminal. So this is the terminal and the boundary within which we have to render everything. And we just render everything within that boundary. Right, so, but what that means is that we need to get rid of this direct access to the terminal, right? So as you can see, we accessing the terminal directly, and we're issuing commands to the terminal directly. So we need to put some sort of like a middleman between the rendering code and the actual terminal. So what we can do, we can introduce some sort of a buffer, right? So we can introduce some sort of a buffer. And the buffer could be like a two-dimensional array of characters, right? So some sort of like a cells, right? And obviously that buffer is going to own those cells, right? So let's actually make them characters. But here's the interesting thing. In Rust, you can't quite easily make two-dimensional arrays in a Fortran style, right? In a Fortran style specifically, right? So I'm being very careful with my words, just to not let the people in the chat say, oh, you can actually do vector of vector. This is a not Fortran style. This is a not Fortran style. Essentially, Fortran style, two-dimensional arrays and also three-dimensional, let's say multi-dimensional arrays actually continues in the memory. They actually completely continuous in the memory. I think C also supports this kind of style of arrays, but they kind of organized differently. I think Fortran organizes them differently. So essentially C arrays, if we're talking about two-dimensional arrays, are row-wise arrays, and Fortran are column-wise arrays, right? So there are some reasons for doing that, but anyway. So these kind of style of arrays are really difficult in Rust, right? They're really difficult in Rust. So the best thing you can do is just have a one-dimensional array and also store width and height and basically compute the shape of the array yourself, right? So we also need to keep track of the width and height. So if you do just vector of vector, it's not going to be continuous in the memory. The rows of the array are going to be continuous in the memory, right? But between the rows, there will be some gaps and stuff like that. Maybe they're going to be in different places in memory, right? Well, they're definitely going to be in different places in memory because they're going to be allocated at different times. Also, quite heavily depends on the allocator, but I mean, who cares? It doesn't really matter because we're not going to be doing that anyway. So, and as far as I know, you can't just do shit like that in Rust, right? So you can't group several variables together because fuck you, this is Rust. So this is how you're supposed to do this kind of thing. So, and that's basically the buffer, right? So that's basically the buffer. So, and interestingly, what we can do. So yeah, some people say you can do things like that, but this is a static array, right? So we need dynamic arrays, right? We need dynamic arrays. So, and I'm pretty sure you can come up with some sort of a cluster Fox solution to support dynamic arrays, but who cares? Let's just have a continuous thing in the memory, right? So that thing works, right? I know you guys like to, rat hole about like little unimportant cosmetic details on how to organize arrays in the memory, but like we just need some data in the memory, okay? Calm down, right? Doesn't fucking matter. So anyway, so we have a buffer in here. And I suppose instead of like providing the usual interface that Crossterm provides to us, we could provide our own interface. We could just like have something like put, right? So, and this is going to be mutable self, and in here we could provide the coordinates, use size, and the character that you want to put in here, right? So the character that you want to put in here. So interestingly enough, if you take a look at this carefully, we also have this style. We also have like a different style of colors and stuff like that. Right, so maybe we should also keep track of that. So maybe each individual cell is not just a character, right? It's not just a character, it's also the color, but it's also foreground color and background color. So we kind of need to take that into account as well. So let's actually introduce maybe cell or something like that. And so maybe it's going to be character, maybe ch. So this is the character. And so fg color and bg color. So as far as I know, we already have a color imported from somewhere, right? So here's the color, and basically we have this two-dimensional array of these cells, right? So and in here we can specify maybe, I think it makes sense to just accept the cell, right? So let's just accept the cell. And that should be it, basically. That should be it, but not really, right? So here we're putting like a single character, right? We're putting a single character, put cell. But quite often, one of the things I may want to do, I want to be able to put an entire string, right? So put str. And putting str is basically going to be you know, doing several, like put cell several times, right? Put cell several times. So let's actually do it like that. So we can put it somewhere like here, usize, y usize. But since we're operating on the level of characters, maybe we're gonna accept, you know, a slice of these characters. Right, and then foreground and background colors for all of these characters, right? Because if we're putting like a chunk, right? So if we're putting like a chunk, we want them to be of the same style, basically, right? So we want them to be of the same style, I think. So let's put it like this. So this is going to be color, and this is going to be color like that. But since it's not a string anymore, right? So should I say cells? Right, so, but then it's I don't know. So maybe cells is a good name. So they're like, I don't really like this kind of names when they differ with just s. But we're talking about you know, statically typed language, right? So very strong, very strict statically typed language. So if I provide incorrect arguments in here, it's just like it's gonna complain about that. So that's totally fine. That should be totally fine. All right. So maybe I'm gonna continue in the same style. So essentially, this is gonna be like a character, and yeah, I'm gonna just continue like that. Okay, so what we wanna do in here, we wanna basically compute the cell and set the, you know, ch there, right? So we want to set ch in there. So one of the things we can do, we can try to get it, right? So we're gonna think about the cells row-wise, right? So essentially, we're gonna have like a two-dimensional array. So here's the row. Maybe I'm gonna have more of them, right, like this. But in a memory, we're gonna store all of that linearly. Right, we're going to store all of that linearly. So that means y determines the current row, right? So we have to multiply y by the width of the buffer, right? So essentially, we need to find the second row, right? So that means we have to take 0 and multiply this size by 2. Right, and that means we're gonna get to this row, right? So we're gonna get to this row, because if you multiply by 2, you basically shift by the size of the width, right? And then we offset by x. So get, if I remember correctly, will return sum. So maybe we want to actually get a mutable one, right? So we want to get a mutable one. So if let sum, and we've got a cell. So here's the thing. So maybe I'm going to still want to call it ch, because then later it will make it easier to do something like this, where I can just do ch fg bg, and effectively I just set that specific cell, and if x and y are out of bounds, nothing is going to happen, right? It's going to just basically silently ignore this entire stuff, hopefully. Hopefully it's going to silently ignore this entire stuff. So interestingly. So we can basically do the following thing. we can find the sort of like a flat index of these coordinates, and we can just move forward and put characters. If we reach the right side, just because we're following in a straight row, we're gonna just wrap around, which is kind of similar to how the actual terminal behaves. Right, it's actually similar to how actual terminal behaves, so that should be fine. So let's actually find this flat index, right? So this is going to be y multiplied by self width plus x, right? So here is the flat index, and essentially maybe I'm going to do the following thing, right? So this is going to be mute, and what we want to do while index is less than the size of the cells, I suppose, right? So this is the count, but we also need to simultaneously move along the cells in here too, right? So which kind of makes it a little bit painful, right? So it kind of makes it a little bit painful, but not that much, to be fair, right? So we can take the cells, we can start iterating them, and we can start enumerating them. Right, so, and let's actually call them ch, right? So for the consistency with the previous thing in here, right? So with the consistency with the previous thing in here. So, and let's do the following thing. So this is the chs, ch in, and of course we're enumerating this entire stuff, so that means we need to have something like this. So that should be fine, that should be fine. So if index plus that specific offset is greater than the size of the buffer, that means we're kind of done doing this entire thing, so we might as well break out of that. Otherwise, what we have to do is just, you know, self put cell, something like, to be fair, we already kind of got the flat index, right? So we already kind of got the flat index, so that means what we want to do, we want to just like do that right away in here. So if let some cell, and let's just reassign this entire stuff back in here, right? Basically. So I think this is the two operations that we'll need in here, right? So this is the only two operations that we'll need in here. Another operation that we'll probably need is an ability to calculate the diff between the buffers, that's for sure, right? But we'll do that a little bit later. So let me try to compile this entire thing and see if it's going to complain. It's definitely going to complain. Okay, so this is not a buffer, this is called cells, right? So what else do we have in here? Cells count is unknown, because it's len, right? Okay, so that's totally fine. And yeah, so this is a huge problem in here because ch is a pointer, right? So can I just like do something like this and automatically dereference? Apparently I can. Look at that. So that makes it a little bit easier, right? So if I have to dereference it like that in here, that means I have to put a little bit of an extra syntactical noise like this, and I don't really want to do that, right? So it's better to like pattern match it like this, and it just looks nice, more or less, hopefully. Okay, so we have a buffer, right? So we have a buffer. And so yeah, we need to modify everything that uses std out to use that specific buffer. So especially when we're talking about the chat, So I'm just thinking, how can we approach this entire stuff? So we need a way to construct that specific buffer as well, right? We need a way to construct the specific buffer. So maybe we can say like a new, where you have to provide width and height, and we can pre-allocate this entire buffer for you, right? So that would make sense, I think. I think that would make sense. So we can basically create the cells, right? So we can create the cells, but then we need to kind of resize them. As far as I know, you can just do something like this, right? So I'm pretty sure. So there was a vec, so rust up doc. There was a vec macro that allows you to just construct those things. Chromium, okay. So in the latest versions of Chromium, I think they introduced some sort of a delay when you type and search for something, right? So for example, if I search for the Rust, there is a little bit of a delay and it's a little bit annoying. I don't remember that delay in the older versions of Chromium. It's like an extra delay, and like, why they introduce that? It's just like, I don't know. So maybe it's just generally becoming slower. Maybe it's just generally becoming slow. It's kind of dumb, honestly. Okay, so there's two versions of vec, right? So the one that you know, accepts just a sequence of expressions, which are items, and the one that accepts the element and the amount of things, right? So, and essentially here we want to say that we want to have width by height of those things. And what going to be the cells, right? What going to be the cells? Cells, do we even have default cells? Maybe we can specify the default cells. Right, so this is actually a very interesting thing. So can I do something like, maybe we could have like a space? Yeah, that's a very interesting idea. Just like have a space in here, and then we can have implementation cell space, right? So this one is just self. And if we do that, ch is going to be just this color, like foreground color is going to be probably black. It's a foreground, it has to be white. It definitely has to be white. And background has to be black, right? So this is the terminal essentially. I don't quite remember. Is this how you do it? No, it's, you actually capitalize it slightly differently. That's how you capitalize it. So this is just like a default space, and we've got the cells in here, right? So afterwards, we probably want to just return cells, width and height, right? So we just prelocated everything, and we don't even have to make this mutable, right? We don't even have to make this mutable. I'm not sure if it's going to compile or not, right? So maybe this thing must be clonable if we want to initialize it like that. We'll see. The compiler is going to tell me, right? So what do we have in here? Expected use size, but got. So do you want me to have a semicolon here? I think it wants me to have a semicolon. All right. So expected use size. That's really, yeah. So the element comes first, and it's separated with semicolon. So I want to actually double check that it is in fact the case. And okay, as I said, it has to be clonable, right? Which is not that big of a deal, right? So it is okay for that specific type to be clonable. Right, so let's make it clonable. Okay, everything seems to be working. But what's funny is that we also need to be able to resize the buffer, because the terminal is going to be resizing, right? So there is one of the events that we're handling here, which is a resize, and we're handling it for a reason, specifically to do this kind of stuff in here, right? As soon as the terminal resize, we need to resize, reallocate the buffer as well, right? So let's actually introduce something like resize, and but I mean, we can just create a new one. But maybe not. Maybe it's more efficient to resize the thing. Does the vector have some sort of like a resize method? Can I do resize? Yes. Resize new length, and you also provide the value, and value is needed when the new length is bigger, right? So if new len is greater than n, then the vec is extended by the difference with each addition slot filled with value. Okay, so you provide the additional value to fill it with. Okay, so let's actually take the mutable self and all of the parameters in here, right? So width and that thing. So let's literally copy paste this stuff in here. We're not going to return anything in here, and we're going to take the cells and we're going to straight up resize them like so. Right, but the value we're going to fill everything with is going to be the space value. And of course we should not forget to you know, reassign the width in here, right? So there we go. So that's how we resize the buffer. That's how we resize the buffer. Okay, good. So it does in fact compile, right? So I need to double check. Yeah, it does in fact compile. Okay, so this is where we create the standard output. Let's create the buffer, right? So this is going to be the buffer, and this is going to be the new buffer. Though we need to provide the size to actually create the buffer. Luckily, we do have already size. We do have already size, and it's this one, right? So we know the size of the terminal, and we can allocate it right away. And this is actually kind of cool. So after we resized, after we handle the resize, we can also resize the buffer, right? So we can just provide like that. Okay, that's pretty cool, actually. It's kind of cool that it fits perfectly in here. So yeah. All right. So okay, so there's some problems in here because these things are use16, so we need to cast them to use size, of course, because it's Rust. It do be anal like that sometimes. Not sometimes, actually every time, right? It is always anal, and that's why I like it. Gotcha, hyper. So there we go. So I think we need to try to factor out everything and start rendering into the buffer instead of the standard output, right? So where do we use the standard output? Okay, so here we clean everything. Maybe we should not clean everything anymore. So yeah, this is basically what probably causes the flickering, right? This is probably what causes the flickering, and we don't really want to do that. We don't really want to do that. So here we're rendering the status bar, right? So we're rendering the status bar. So let's go ahead and try to replace QC with the buffer, right? So we're now accepting a mutable buffer, and let's see what we can do in here. Let's see what we can do in here. So I'm going to start at the compilation stuff, right? So, and I'm going to go to the compilation errors. So in here, I'm moving specifically to X and Y, right? Then I set the background and foreground, and I print the label. Okay, so essentially, this is a single put cells command, in fact, right? Moving to specific coordinates, setting background and foreground, and then printing a bunch of things. This is a straight up a buffer put cells, like a single put cells, actually, these 4 commands, which is actually kind of cool, right? So it makes it sort of like simpler in a sense, right? Because you don't have to do it like that anymore. So we can provide X and Y, right? So we don't even have to cast it to use16 anymore because it's already use size. That's pretty cool, right? So we don't have to do that. The only problem that we have in here is that we have to convert it to characters, right? So that means we'll have to re-encode it a little bit, which is not that big of a deal. I wonder, it would be kind of cool if there was like an easy way to just, you know, convert a slice of str to a slice of character without recollecting everything. Like, obviously I can, you know, iterate and maybe collect. Yeah, I have to do chars, right? So that gives me the characters, and then to get the you know, slice of this entire thing, I'll have to collect that into some sort of vector, right? Into some sort of vector, and I obviously don't want to keep that vector for very long, so it's going to be a reference to like a temporary object, right? So, which looks freaking ugly, like anything in Rust. So, just a second. All right. So, and we have foreground in here. So FG, so the background is supposed to be white. So that means this one is supposed to be black, right? So this is black foreground, and background is supposed to be white. So that's what we'll put in here, right? Like this. And that should replace like this entire thing in here, right? And that should replace this entire thing. So, and afterwards, so this one is really convenient in a sense that we basically, yeah, we keep moving afterwards. So it's when we render in the status bar, right? So we render in the status bar, we just render the label, and then we fill everything with these spaces until the end, right? And because of the how the cursor behaves in the terminal, it is actually super easy to do it like this. So yeah, but now we have to be super precise about that, and to be super precise about that, we have to know the characters of this thing to compute everything perfectly. So maybe I'm gonna factor this thing out to a separate variable, even though I didn't want to do that. Right, so even though I didn't want to do that, so this is gonna be labeled chars, and maybe I'm gonna say that this thing is gonna be a vector, so I don't have to provide the vector in here, right? It's going to infer all of that stuff automatically for me, and because of that, this thing becomes a little bit simpler. It becomes a little bit simpler. Right, and now, so what we're doing here, we are iterating from 0 to w as usize, but minus label. Right, and w, why do we cast w to usize if it is already in usize? Why the fuck was I doing that? Well, I mean, I kind of know why the fuck I was doing that, because I probably, at some point, maybe it was U16, and I just copy-pasted that code, which is totally fine, So sometimes code evolves, changes over time, and it gets kind of weird, so that's normal. All right, so we don't really need to do that anymore, right? So we don't really need to do that anymore. But interestingly, since we kind of plan to sort of have, yeah, it would be better to maybe have this as another x, right? So this is going to be x iterating from here up until the w, right? Up until the w, so then it is easier for us to put a single cell, right? Put a single cell at x and y, and x overshadows that specific x, but y is that y, which is super convenient in this specific case, right? And here we put a single space, and we use the same sort of style for the characters. Thus, yeah, I really like that. That is pretty cool, isn't it? I think that is pretty cool. All right, so let's actually try to recompile this entire thing. And what does it say? Right, so we don't have to do that anymore. And so there's some warnings, but is there any errors? Yeah, there are some errors. I can see that. So yeah, so here we're passing the std out, right? So we're passing std out, and instead of passing std out, we have to provide the buffer, like so. So any errors? I think there are some errors. Yeah, there we go. That's really, oh, okay. So we did that status, okay. That is very cool. So we use status bar 3 times actually, right? For the top thing and for the bottom thing, and also depending on the bottom thing, whether it's online or offline, we just render different text, right? So as you can see, yeah, so we do it like that. Okay, so that makes sense. So we're now rendering this entire thing into a separate buffer, right? So we're rendering this entire thing into a separate buffer. It will be kind of interesting to see how exactly it looks like after rendering everything into a separate buffer. So we could have basically, you know, broken out of the loop, right? So we have sort of like an event loop here. So we do one iteration, we break out of the loop, and maybe it makes sense to actually reset the row mode afterwards, right? So we reset the row mode, and let's go ahead and do that like so, and try to print the state of the buffer. In fact, we can just go ahead and try to print it in debug mode, like so, just to see what's inside of the buffer, right? It's going to be garbage, but I still want to see that. You know what I'm talking about? I still want to see that. So let's try to compile this entire thing, and so it's not really printable, isn't it? Right, so this is going to be struct buffer. Let's make it printable. So we're going to derive debug. And let's go ahead and try to compile that. So it still complains because this is because cells are not debuggable. Let's also make them debuggable. Right, so they are debuggable now. And boom, yes. So now let's try to run this entire thing. So it's going to be bin client. And that's a lot of things. That's way too many things. And I don't really like that. So, okay, we can try to maybe iterate through all of the cells in the buffer, right? So we have buffer cells. And so let's take a cell. And maybe let's print only the cells that are not spaces. Right, so we can say if cell ch not equals space, just print that specifically. Right, because we know that majority of them are going to be spaces anyway. We're interested in those that are not spaces, right? So this is going to be ch like so. And let's go ahead and do that. So that does not compile properly. So we cannot ch in that scope. All right, so we can say ch. Well, I mean, let's print the entire cell. Right, let's print the entire cell. Okay, so what was it complaining about? So attempt to subtract with overflow. I didn't expect that shit to happen. Ooh, this is because the height was too small. Yeah, we should not run it within Emacs because Emacs is not particularly great terminal emulator, especially in the compilation mode. Yeah, so in compilation mode, I don't think you can have interactive applications, so that's fair. That is actually fair. So this is going to be bin client, so let's actually see. Okay, so we got some shit, which is funny, right? So yeah, we have for at, and then start. Okay, so but it actually printed them in a very scuffed manner, right? I don't really know why. Right, even though I asked it to reset everything in here, so that's kind of funny. That is actually kind of funny. What if we don't flush this entire thing? I think flushing like ruins the terminal, so let's actually not do that. Yeah, but still, but I mean, you can already kind of see. So here is for AT. Then STA, which is status offline, right? So these are the cells, right? So these are the cells. That's actually pretty interesting. Okay, so we kind of can see the contents of that buffer, right? So, and I think that's quite important to know that something is happening in there. Oh yeah, I see what the fuck is going on. Okay, so I enabled the raw mode. What I'm supposed to do, I'm supposed to disable it, I think. Right, so I'm supposed to disable it. So maybe disabling it actually is going to help and make it a little bit better. Yeah, there we go. So as you can see, for at status offline, and this is exactly what we saw at the bottom in of the application, right? So essentially we just captured those things. We just captured those things. So we can even see maybe coordinates of each individual thing, but we'll have to recover those coordinates. So one of the things we can do, obviously, we can enumerate this entire stuff, right? So we can enumerate, and there we go, we've got a flat index, right? But to be able to use that flat index, we'll need to convert it to the thing. So y is actually quite easy. You just take index and divide it by the buffer width, and you get a y, and x is going to be the same but mod of the buffer width. Right, so we can get x and y, and it's actually rather easy to just do something like this, right, and see at what coordinates you have all of that stuff in there. So it didn't like enumerate because we're not actually enumerating anything. Right, so let's rebuild this one more time, and if I try to run that, so here are the coordinates. So this one at the column 0, 0, and the next one is at the column 22. Right, so the one is at the bottom, and another one at the top, and another one it's at the bottom. So we can clearly see their coordinates. So that's actually pretty cool. That is actually pretty epic, meine Freunde. And we can see foreground black, background white, blah, blah, blah. As usual, as freaking usual. Okay. So that is pretty poggers, in my opinion. So we don't really need that stuff anymore. All right, so we don't really need that stuff anymore. And obviously, let's actually flush again. So that was the status, right? So that was the status, that was easy. Now rendering the chat itself. By the way, maybe I should have not actually removed that code. You know what? I think I should have, yeah, I should have kept it, right? So because I think it's going to be useful in the future as we continue basically migrate the code to a new way of rendering things, right? So by the way, buffer, this buffer thing is basically the virtual DOM, but it's more like a virtual buffer, right? So it's like a virtual buffer. It's like a virtual DOM. So okay, client f render. So instead of accepting this thing, we have to accept the buffer, and let's see how it is going to go. So, oh, and we're actually rendering, yeah, so the chat log needs to render things with different colors, by the way. It needs to render things with different colors, but we do support colors in the buffer, so that's totally fine. Okay, so here we have a buffer. Let's go to the compilation errors. Boom. Where are the errors? Okay, so here we're moving to some sort of a boundaries, right? So X and Y boundaries, and then we're printing a certain thing. That is easy, chat. What the fuck? Buffer put cells, right? So buffer put cells. And so what was the signature? So X and Y. We already have an X and Y. In fact, we just have to use boundary X and boundary Y, dy. Can you see, by the way? I think it's kind of difficult for you to see. Yeah, but maybe I should just make my stuff a little bit smaller. All right, so we put a cell, then we have to put the line. And the line that we've got, what is the line? So we iterate in the items of a chat log. And what are the items of the chat log? They are strings, unfortunately. So that means we'll need to convert them to characters nonetheless. All right, so let's do line chars, because why not? Which is kind of dumb, but maybe we're gonna make it a little bit better later. Right, so this is gonna be line chars. Collect, right, so here's the line chars, and in here, so we might as well just do it like that. So now we have to use line chars instead. That's a good one. I think that's a good one. I'd like to maybe like separate that a little bit. Can you see that? I think it's kind of difficult to see, but yeah, I think it's more or less visible. So, and then we have to provide the color. So when we provide the color, so the first one is a foreground color, right? And for the foreground color, we do have the color in here. And the background is basically black, right? So it has to be black. So, and we replace these two lines with this single huge ass ugly line, which is great. I really like that. So let's take a look at the errors, and okay, so it only complains in the place where we call to this entire thing, so now we have to just replace it with a buffer. And this motherfucker compiles, apparently it's that easy. Okay, so why is it so easy, excuse me? Right, so, okay. Yeah, well, already, like, all of the status bar are rendered in a buffer, client is rendered in the buffer, so that's basically it. So the last thing we render in here is the prompt, which is rather interesting, right? Because why prompt doesn't have its own rendering code? That's kind of bizarre in my opinion. You know what? I think I'm gonna continue with the prompt after a small break, because I've been already streaming for like 1 hour, right? So I ran out of tea. I need to refill my tea. And you know, once I finally have T again, I will continue slapping the code. So what I want you to do, I want you to actually factor out the rendering of prompt to a separate, like a render function, if you know what I mean, right? So separate render function. So in here prompt, how do we even render the prompt? So status bar, we always like we provide the width and height. So yeah, so I do have a prompt somewhere here. So here it is. So here is the prompt, and it does a lot of things in here, right? So primarily controls and stuff like that, but we want to be able to just render this entire thing. So we're gonna accept the mutable self, and what I'm gonna do, I'm gonna simply move this entire stuff to there, right? So this is gonna be client. The prompt is not located within the client, so what I have to do here is just prompt render. Right, so then I'm gonna go to render, copy paste everything in here. So I'm gonna call the compiler just to see what exactly do I have to provide in there. Right, so exactly what do I have to provide in there. So here I'm gonna replace std out with qc, right, and qc is gonna be just you know, a mutable reference to the implementation of queuable queuable command, right? So that's what it is. Right, so let's go to the compilation errors. We'll also have to provide width and height. So it's going to be use size, like so. Though I'm not quite sure. So height, this is more of a actually position, right? So this is more of a position, I suppose. So we have to provide X and Y, and like where the prompt starts, and we have to provide the width, how wide it is, right? So how wide it is. So that's the only things we need in here. Okay, and this one is rather interesting. So we have to move to X and Y, right? So as U16. As U16, and so what else do we have in here? So prompt, this is actually self, right? So this is actually self. What else do we have in here? And the prompt is the buffer. This is actually self. So within the prompt, we actually store the vector of characters, which is correct, right? So it is in fact correct. I'm not quite sure. Why do I do W-2 in here? It doesn't make much sense to me. Maybe it's basically leftover from some sort of like cosmetic decoration from left and right when I was trying to put a frame in there, and I just forgot to remove that. That's what it feels like. Right, because I didn't think it's relevant right now, right? So I didn't think it's a thing that I should be worried about. So yeah, fuck that. And that's basically it. So what else do we have in here? So clear is unused, all of that stuff is unused. Okay, so in this thing may actually fail, right? And if I take a look at how other FN renders work, we do return IO result in here, so that's fine. Right, so where is the other FN results? So we're gonna do it like that. So here everything is fine, and if we reach this specific place, that means no error has happened. That's totally fine. Okay, so in here what we have to provide, std.io. We have to provide the position, and the position was what? I think it was 0, h-1, or maybe yeah, I think it's h-1, and in terms of width, it's the full width. So that's basically it, if I'm not mistaken. I think that is basically it, hopefully. Right, so, and that's the last error we have in here. So all of that stuff is has to be use size. So let's actually explicitly say as use size. So let me put it in here, and it compiles mine for in there. So and by the way, I should probably also put a question mark in here. Right, so we're going to put question mark in here, and everything seems to be fine. Okay, so I factored out the you know, all of that stuff into separate functions. So now I can migrate this function to actually accept the buffer instead of queuable command. Right, so let me actually see where is that thing. So this is going to be buffer. So it's kind of a weird way of doing that. I could have like right away rewrite it, but I don't know, I felt like first factoring it out and then migrating it to a different mechanism. I don't know if I made a mistake in here, but I mean, who cares? Okay, so what are we doing here? So we're basically trying to, yeah, we might as well just take this, right, and collect that into like a characters, right? Not really, because we're taking a slice, which kind of works out. So that means we can buffer put chars, put cells, I would even say. Put cells, and put cells accepts x and y, and yeah, so then the characters. So the x and y is going to be like this. The characters is going to be just that, because it's already a slice. We don't have to do shit in here, which is super nice. So the foreground is going to be white and the background is going to be black. So that's basically it, actually. So this could be just a single line. Just a single line. Surprisingly, it's not gonna return any IO errors. In fact, after we migrated to just buffers, no IO errors while rendering are going to happen, because what we're doing, we're just placing characters into the memory. No actual IO is happening. IO is gonna be happening at the end of the iteration. Right, when we actually computed the diff between the buffers and we prepared the patch, and then we're applying the patch, this is where IO errors will happen. So we might as well get rid of all of these IO errors within the renderers, all of the render functions. Okay, so let's go to the compilation errors. What else do we have in here? So yeah, so we have to now accept le buffer. Okay, and it seems to be working, but we don't really know if it's going to work or not, or whatever. Okay. So we're rendering the entire frame into a separate buffer. It is not particularly useful, right? So we can print whatever is located within the buffer, so maybe that is going to be useful. Right, so, okay, which is understandable, yeah. So there's nothing in the prompt, there's nothing in the chat. So because of that, we don't see anything except the status bars. Anything except the status bar. We can try, one of the things we can try actually, we can try to do chat, maybe, let's do chat error. Right, so there's going to be chat error, client, chat, is that how you access it? Yeah, so client chat, you have to provide the mutable, and we can put something like hello in here, and that should add like 5 red characters to the whole frame, right? So that's going to happen, right? And here they are. So just a second. So here's the hello, right? Hello, and the foreground for them, as you can see, is in fact red. The background is black, but it's red. So this is what we have in that sort of back buffer that we didn't really realize on the screen or didn't actually render. Right, so this is like actual like cells in its coordinates, its styles and stuff like that. So that's what we have in here. This is basically the virtual DOM, right? So this is the virtual DOM, basically. So what we need to do, we need to be able to maybe have actually 2 buffers, right? So essentially one buffer is the current one, and another one is the previous one. Right, so yeah, we need 2 of them, in fact, right? So it's going to be car, buffer car, and buffer previous. So, and to keep things shorter, I think I'm going to actually call them buff car and buff previous. So what we're rendering everything into the current buffer. Right, we're rendering everything into the current buffer. So let me go to the compilation errors, right, because that should create the compilation errors. But yeah, so if we're resizing, we have to resize both of the buffers. So that's interesting. Okay, so buff current and buff previous, right? So we're resizing both of them. what else do we have in here? So yeah, I might as well just query replace all of these things with buff car core. There we go. So do we have any other things in here? So yeah, we might as well query replace that with just that. It's basically, that's a good analogy actually. Yeah, it's basically like a double buffering. But isn't virtual DOM in React also kind of like a double buffering, isn't it? Well, it's not really double buffering, yeah. Because we're not going to be swapping the buffers. We're going to be computing the diff between the buffers and apply only the diff. So it's really closer to virtual DOM rather than double buffering. So, So I don't think it's really a double buffering. It's more like a virtual DOM. So, interestingly, we need to extend the buffer. We kind of need to extend the buffer. So maybe we could introduce something like diff. Right. So it's gonna accept self and something like other, which is the pointer to self, right? So the other buffer, and we'll probably return you like a vector of patches, right? So some sort of a vector of patches. And what's going to be the patch? That's a very interesting question. So patch is essentially like a cell plus its coordinates, right? So we can say cell and then x and y, right? So basically it says you have to replace that, like at that coordinate, put this specific cell. So I think that makes sense actually. Yeah, so, and we just need to do that. So we may assert something, for instance, that self width is equal to other width, right? So we want to make sure that their shapes are the same, right? So that's quite important, I think. Shapes have to be the same. Let's actually combine all these things together. Yeah, so that's what we assert. Afterwards, I'm not even sure. Right, so maybe patch has to be a flat index. Can we just make it a flat index, or maybe... Because it's obviously way easier to have something like n, which is the self cells count, and just iterate like this, and basically just use I without converting to coordinates and stuff like that. Though converting to the coordinates is not that hard, as we know. Right, so you can just do it like that, and there you go. I already converted everything. I don't even have to think about it. So maybe I should have just done it like that, and I already did. In fact, right. So yeah. So here's the x and y, and essentially what we can say, if the self cells I not equal other cells I, we just add it to the patch. Just add it to the patch, meine Freunde. Just add it to the patch. Maybe we can even go full comp Sawyer shit and zip together all of that stuff. Oh fuck, it has zip. Oh my god. Ooh. True comp soy language, I swear to God. It does, it literally has a zip. Wannabe Haskell. Wannabe Haskell. Okay, so what we can do, we can just take self, cells iter, and other cells, zip it with so into iterators. So we might as well just maybe then take it like that, zip other cells. So we zipped those mother flippers together, and now what we have to do, we have to filter them, right? So, and here we are going to have basically A and B. right? So this is A and B. So these are the cells. If we are filtering them only if they're not equal to each other, right? So filter the ones that are not equal to each other. So this is the ones that we're interested in. But we need to have coordinates, right? So we need to have coordinates. So we need to enumerate them, right? So we have to enumerate them. After we enumerated them, we need to map them. So then we can convert to like X and Y and stuff like that. So, and essentially, so here is the enumerator, and then we have A and B. Though the only thing we're interested in is the B, right? So we're not interested in A. We're not interested in A. We're only interested in B. So here is going to be the patch. So we might as well just do the cell. Then we can quite easily convert this entire stuff to just this. So this is going to be cell, X and Y, and we've got the patch. So then after that we can collect this entire thing into effect. All of the comp soys are fucking coming right now. I'm not even sure if it compiles or not, but we'll see, we'll see. So obviously we'll need to implement the non-equality and stuff like that. So all the comp soys are fucking coming. So yeah, that's basically how you program in Haskell, right? Look, man, no loops. Yeah, exactly. No loops. So let's see if it compiles or not. I'm pretty sure it doesn't compile. So zip is not an okay. So we probably want to do something like this, right? So that's what you want. Into it, I really want to actually avoid that. So it wants me to do it like that. And you mean I also have to do it like that? It's kind of dumb, honestly. It's kind of dumb, but yeah. Okay. So this is a cell. So I wonder if I can just do something like that. Can I quickly? Yep. So it's not applied. So we need a partial equality for this cell, right? So where is the structure cell? Let's make it partial equality, right? Do we need anything else? I see what's going on. So it wants to, yeah. So it's also pattern match it like that. Okay, so what else do we have in here? Cannot move out of the shared. Okay, well, we can clone the cell. I don't mind that, though maybe making the cell copyable is even better. Who freaking knows? Who freaking knows? So something cannot move out of the shared. I just realized that I don't fucking understand what the fuck it wants from me. So maybe we could have just done something like this. Cause maybe because we use self in here, but it would have told me that, right? So it would have told me that. Cannot move out of the shared mode. Move occurs because these variables have types that don't implement the copy trait. But then it doesn't. Okay, so I managed to crack the puzzle. I cracked the puzzle. Crack the puzzle. That's what I wanted to say. The vowels in English are fucking hard, honestly. Like, is it so many vowels? Why do you need so many vowels, English people? Like it's just like, why? So hard, honestly. Yeah, so that's basically the patch, right? And how we're gonna be applying all of that? That's a very interesting thing. So after we rendered everything, right? So after we rendered everything, so obviously here's an interesting, funny thing. We clean everything in here and we move. I think I need to move this kind of stuff closer to here. Right. So we clear everything. I think the buffer needs to have a way to clean the entire screen. I'm pretty sure it needs to have something like that. So let's actually do buff car clear. All right, buff car clear, and clear I suppose is going to fill everything with a space, right? So that's basically my idea, right? So implement buff and so this is the diff fn clear. So going to be take commutable self, and can you just take cells and fill everything with cell space? Is that something that is feasible in Roost? It is, in fact. Buff car clear. It is actually feasible. So, okay, what we need to do now, we need to take the previous buffer and find the diff between the current one. And that gives us the sequence of patches, right? So it gives us the sequence of patches that we can try to iterate. So this is the patch. So we might as well even do something like patch. So here's the cell X and Y. So we extracted cell X and Y. And essentially what we have to do in here, we have to move to X and Y, right? So this is where we actually perform the IO stuff. So we move to X and Y. And we need to just print with style, right? So I think I already removed the code that does that. Print, right? Print styled content. All right. So that's another thing that we need to put in there. So we need to take the cell ch, right? So this is the thing, right? Might as well, by the way, pattern match it even further. Cell chfgbg, right? Chfgbg. So with the foreground color, and so let me just double check. I need to probably do cargo docs, right? So I need to have some docs in here. Okay. Styled content. So I want to take a look at the methods in here. So with, and the background is on. Okay, so you provide foreground with and background with on. So yeah, that's how we do that. So ch with fg on bg. There we go. So, and we're gonna do std out q. We're queuing that specific thing, right? So we print it like that. And afterwards, we just need to flush this entire stuff, right? So we're just flushing it. We're simply flushing it. So I suppose we don't really need to break anything in here. So yeah. That's pretty cool. And I suppose now, after we computed the difference between the current and some other buffer, we need to essentially swap them, if you know what I mean, right? So we need to swap them. Though it's not as easy as it may sound, right? So we can just do the copy, though. We can just do the copy. Is there something for vector copy? Is there something you can do in here? So there's a mem copy, but it's probably unsafe. No, it's not really. Huh. It's a nightly. Freaking Rust. Anything useful isn't is in nightly. So yeah. I guess we can just do the clone, right? So we can always do buffer previous is basically buffer current, and just clone it and leave it as it is. It's kind of slow, but I mean, who cares? Who actually cares? So one of the things we probably want to do, by the way, is clean the entire screen right before rendering anything, right? So we just do std out, q, and then we want to do one single flush, right? So we want to do one single flush. It's just doing one single flush, and we probably, yeah, so that way the previous buffer is synchronized with what is actually on the screen, right? It is synchronized with what is actually on the screen. So that's pretty cool. That is very, very cool. So let me try to compile the entire thing and go to the compilation errors. So what's going on here? Well, parsing the fields, that's really bizarre. Oh yeah, so that means I have to do something like this. Yeah, that's true. What else do we have in here? Print is not used. So we have a bunch of unused things, but I'm not really interested in those. What I'm interested is these things, right? So as u16, might as well as u16, as u16. I wonder if I can pattern match them like this, if this is something that Rust allows you to do. Expected, yeah, you can't just easily do that, but I mean, we can just move it in here. We can just move it in here. So errors. U64, U16, that's what it went. Is that it? No, I didn't believe that. And of course we have these things in here. So buffer is not clonable. Okay, that's not a big deal. Let's make it clonable. Cool. So we have some unused stuff. So this is not interesting. This one is interesting, right? So when I put the cells, I thought that I'm gonna have these kind of problems. Okay. It doesn't have to be mutable. Yeah. So we may actually call it something like start. Yeah, so this is something like start, and this is more like an offset. All right, so start and offset. And yeah, there we go. So do I want to remove? Nah, I'm going to keep the warnings because I'm not sure if I want to keep this kind of stuff or maybe I'm going to use them in the future. Yeah, it's kind of interesting. So what if you have a streak of patches with the same background and the same foreground? You probably want to basically set the background and just print the things, and then when the background changes, like set it to something else. That's a very interesting idea, actually. Yeah, so that way maybe it's going to be more efficient. So how many years I need to learn programming to be so fluent in it like you? I've been programming personally for 18 years already. So I started to program when I was 16. So it's 2006, right? So 2023, right? So yeah, so 18 years, at least, right? So at least 18 years. So if you don't have this much experience, don't be too harsh on yourself. Maybe after 18 years, you're gonna be even more fluent than me. But to be fair, being fluent, whatever that means, if you mean like typing code quickly, it's not really that important, right? So it's not really that important. It's not how quickly you type the code, it's if you type the correct code, right? So essentially, if you know what to type, you can type it very slowly and you can be more efficient than the person who doesn't know what to type but types very fast. So it's not about, you know, being fluid or anything like that. All right, so let's actually try to run the client and see if it does anything, right? So we're gonna do client. That's actually kind of funny. Because, well, I mean, it kind of works, yeah. It kind of works. It puts something on the screen, right? I'll give you that. It puts something on the screen, but I think it just ignores X completely. Yeah, which is kind of funny, right? Why did it ignore X completely? So is that because we just I don't really know why, because we're setting the cursor, right? Then we're printing with a specific style. Though the style is kind of weird, right? So here, for example, it is black, but maybe the color has to be reset, right? So for instance, yeah, if I take a look at the chat error, so we set this thing, but when we render the chat, so here's the chat log, and as a background I set black. Maybe I should set reset. I remember there was a reset color or something, or like a blank. Yeah, so there was a blank color. So as you can see, there is like a harsh black in the background of hello, right? So don't mind that it renders everything completely incorrectly, but the color itself, it kind of indicates that I'm just using the background color incorrectly. So what I'm thinking is that now it is going to do that more correctly. No, it didn't actually, surprisingly. Huh. So maybe that doesn't really matter. Okay. So I do not quite understand what's up with the coordinates. Maybe we compute the coordinates incorrectly. So that could be the case. So when we're computing the diff, right? So when we're computing the diff, maybe that's the problem somewhere here. Yeah, it is. You know why? We enumerate shit after we filter out things. I mean, really? So yeah. Yes. So it has to be more like this. So we're gonna try to rebuild this entire thing, and if I try to do that, that looks a little bit better. That looks a little bit better. It's kind of interesting that it has this sort of like a trail and everything. By the way, I can finally select shit. I can finally select shit because if nothing changes, it doesn't redraw anything. So let me show you something interesting. I'm going to stash everything I developed today. I'm going to rerun it one more time. Right. So I couldn't select shit. Like, you see, I'm dragging around. I couldn't select shit. Guess, like, I mean, you can kind of see that it like blinks with selection, but I can't select shit. Guess why? For the same reason, the Windows is flickering. The Windows is flickering, literally for the same reason. But since Linux is like a professional operating system with a higher frame rate than this operating system for video games, you can't see the flickering. You can't see the flickering because obviously, like, Linux is faster. But you still cannot select. But now, since we're not redrawing like 60 frames per second, it is actually allows us to select things, which is kind of cool, right? So let's do that. So a visible result, like actually visible result. I think it's kind of cool, right? So now I should be able to select hello, right? And I can probably even. What's funny is that I selected it, and it doesn't even disturb the selection because it doesn't modify it. It may disturb the selection when it starts to wrap around. Ah, look at that. It doesn't even disturb that. That's actually super cool. And this is probably because we don't even clear anything. This is so cool. So there's still this kind of thing I don't quite understand. So there's something about how we use the background color. Though rendering this thing, as you can see, doesn't create this weird trail of the background color. So yeah, That is kind of bizarre, meine Freunde. That is kind of bizarre. But what I can do for sure, I can probably finally delete this to do. So because that to do is basically done. That to do is basically done. So, and by the way, I think we need to move the cursor after. Yeah. So after we rendered everything, I think that's kind of important. So. We rendered everything, we moved the cursor where it's supposed to be, where it's supposed to stay, then flush, then we swap the buffers, we wait a little bit, right, and everything is Gucci, everything is Tamaguchi. So everything is Tamaguchi. So let me see how we render the prompt. We just set the background to black. And that is it. And I can't understand why the fuck it is like that. Let me try to run this thing one more time. And let me... Oh! It doesn't have that stuff anymore? Oh. Am I going crazy? I think I'm going crazy. So if I say there's no this is a known command. So there's something so I suppose what I have to do here is just use reset. So the reset actually worked. Yeah, okay, so I think I figured it out. Almost though. So that means fn space reset. And I wonder if I can use reset for the foreground as well. That's a very interesting thing. Can I use reset for the foreground as well? I think I should be able to. I can. I think. Maybe it doesn't matter, but I mean, yeah. Okay. And everything seems to be working. So yeah, now we're not refreshing on each individual frame. Now we're keeping track of the state of the entire screen in a shadow, in a virtual buffer, just like virtual DOM. We're computing the differences. And we're applying only the differences. And this is very freaking important, my friend. Virtual buffer indeed, that's what it is. So I want to try this idea where we're not using print styled content, but we're actually using set background color. And essentially, if you have a streak with the same style, do not reset the style over and over again, only set it once. I think this is actually quite the case, isn't it? I think it is quite the case because, for example, when we're rendering the status bar, right, when we render the status bar, you can clearly see that we set the style once and then we have this like a streak. So we want to only set like style once until the end of that streak. So I think that kind of makes sense. So yeah, let me see if we can pull that off. We may want to maybe keep track of the style somehow, right? So we can say fg current, which is going to be color reset, right? So and bg current color reset, and we might as well just set them all. Std out q set foreground fg current, and of course they have to be mutable because we can modify them. Set background bg current. Okay, so we just set them. Essentially, we move into x and y, and one of the things we want to do, if fg current not equal to fg, right? It's not equal to fg. We set fg current to a new one, right? And literally set it like that. And we repeat that for the background as well. I think that's a good idea. That's an interesting idea, actually. I'm not sure if it affects anything. Maybe it's not really that important. So, and because of that, we don't really need to have like a print style. We can just print that character like this. And that's basically it. All right, so what is it complain? Oh, because of the parentheses, of course. This is the most important thing for roosters, is to never use these parentheses. That's the most important warning for them. Okay, so let me see. All right, that didn't work. That didn't work because I'm a dummy dum-dum. Okay, boom, first try, that was first try, that was first try. Okay, go. So, interestingly enough, can you try resizing? Okay, that's a good idea. Good enough. We can just clear them all. I mean, it's not that big of a deal. When we resize, we can just clear them all. I mean, we can probably clear them inside of the resize. Who said we can't do that? I think we can. Self, cells, fill, cell, space. It's not really like a space anymore. Maybe it has to be like a default. Yeah. Maybe we can also call it. Yeah, well, whatever. Doesn't matter. Don't want to ratful about it too much. Okay. So it doesn't help because I was hoping that it's going to like literally reset everything, but yeah. So I suppose we also need to clean the clear the actual thing in here. So let's do it like that. So if you resize, not like this, resize. I'm also going to do something like that. I don't want to print anything. Okay. I mean, so just clear. Just clear. Makes sense to me. Makes sense to me. That's pretty pogue, in my opinion. So is there anything else that is left in here? So here is an interesting thing. We can also keep track of the current x. Current x. So if the x, the current x is basically previous x but plus 1, we don't do any move in here. You know what I'm talking about. So essentially, if you're rendering consequent cells on the same row, there's no kind of any point in moving anything. Because you just place one character and that's it. I think it would make sense. Right, I think it would make sense. Maybe we could also keep track of the, you know, previous, you know, x previous. Right, so this is x previous. And y previous also 0. And essentially, if y previous equal to y and x previous plus 1 equal to x, there's no need to set anything. So it's kind of like we have to do the opposite, right? If it's not that, only then we are queuing that stuff. We can apply De Morgan law, right? So essentially, we can get rid of that negative. If this thing not equal to that, or that thing not equal to that, and completely get rid of that, but I don't think it's became readable. Quite often when you apply De Morgan law, it becomes less readable, at least to my taste, right? I prefer not to apply De Morgan law in here. we're not optimizing circuits, right? That's not what we're doing in here. Right, so we're not optimizing circuits to trying to get it to a very specific set of elements. We're just trying to write a readable code. And I think, yeah, speaking of readability, anyway, so, right, because you have an action, you have a condition, and you just negate that condition, right? And you want to keep it that way, right? Because that's straightforward. So anyways, I wonder if it's going to work. So, and essentially, at the end, we will need to, yeah, we can do x previous equal to x and y previous equal to y. So maybe that reduces the amount of actions you have to make. And let me see if it's actually changing anything. It's kind of working. Maybe it's even faster. Who knows? We can try to see how it plays out with the server, right? We can see how it plays out with the server. So I'm gonna put it in here. I'm just thinking. Yeah, so the server is going to be down there, right? So the server is going to be down there, and can I just run the server? So here is the server. And the client, we're going to have two clients in here. So the left client and the right client. So let me maybe open the token, so it's easier for me to copy paste it like so. And I'm starting the client, and I'm going to be starting another client. And I'm connecting to 127.0.0.1 with the token. There we go. Hi. Okay, so let's connect to another one. I'm connecting to 127.0.0.1, another token. Hi, and it updates as I receive messages, right? So even though it doesn't update all the time, it updates as I receive messages. So which is actually kind of cool. Right, so I mean there's a rate limit and stuff like that, but yeah. So, and I can select things, right? So it doesn't refresh anything, so that's pretty poggers, right? I wonder if that fixes everything on Windows. Unfortunately, I don't have a Windows, but I can commit. The changes right now, and if we have any Windows users, right, in the chat, you can guys tell me if it actually fixes anything. You can find the source code in here, and I'm about to commit some changes. So might as well first maybe get rid of the unused things, so we don't really have reset colors or anything like that. Right, so we got rid of all of the warnings, right? So we got rid of all the warnings. Implement virtual DOM for terminals. Right, so I just pushed that. So do we have any Epic Windows users in the chat? Please confirm that there's no flickering, that it works fine. Maybe we could do a DDoS session. How about some epic DDoS session? So the last time not that many people joined the DDoS session. So the hypothesis why not that many people joined is because of the bug, and we have a lot of gamers in here apparently, or because people didn't know how to fucking use it. Right. So just in case of the latter, so I'm gonna show how to use the client. So you do cargo run --bin client, right? So that's how you do that. Then you put /connect. There is a little bit of a tab auto completion, right? So you do /connect IP. The IP is available in a secrets channel on the Discord, right? So right, there we go. So we have a Discord thingy, and so there's a secret channel. If you can't see that channel in the Discord, you're not supposed to. People who are supposed to see that channel, they see that channel, right? So namely, specifically the subs, right? So you have to subscribe to be able to see that channel. So right, so the IP is going to be available in here, right? So IP is not a secret, by the way, so that's why I'm showing it. And also there will be a token. So and essentially you provide the IP and you provide the token, right? So the token that I will provide, and you just connect, right? So you just connect like that. So that's how it works, essentially, if anyone was interested, right? Okay, so all of the changes are pushed, all of the changes are available, so I think the time has come to try to deploy that to your mom. All right. So let's go to TeamUX. I didn't make any changes to the server, so that should be fine. So, but I'm gonna fetch the changes just in case. Origin, there we go. So git merge origin main, git merge origin main. So let's do cargo build. Let's do cargo build. There's no more flickering. Oh, okay. So there's no flickering with, but the resizing makes every cell white. Okay, so let me actually see what's going on. Copy link. Just a second. So don't resize then, I suppose. Oh, I see. Okay, that's very interesting. That is very interesting. That is very interesting. I suppose the reset color on Windows is not the same as on Linux, right? It's not the same. All right, so that's kind of funny, actually. That's kind of funny. All right, but maybe we don't even have to DDoS that, right? If we know that. But we can DDoS that anyway. Okay, so I promised the epic DDoS session, so let's actually do that. All right, so I'm gonna try to connect as well. So how many people we have? So, hi, it's me, Zozin. So we need a way to actually tell how many people we have in the chat, right? So my backspace is mapped to H instead of backspace. Okay, that's kind of funny. At least 2. All right, so people are sending things, so that's cool. Okay, so this is the stuff. What's all with the empty messages? So essentially, the server sends a new line, even though it shouldn't do that, but it's just like an artifact from the previous version of the protocol. So I will fix that at some point. So that should be fine. All right, so Windows users say that everything works fine, right? So the only problem is that when you resize, there is like a white cells and stuff like that. But this is because I suppose the color reset on Windows is completely different, right? So the color reset is completely different. But I'll look into that already after the stream, I think, right? So I'll look into that already after the stream. So we already did the main sort of chunk of the work. We implemented the virtual DOM, if you know what I mean, right? So we implemented the virtual DOM. And right, so all of the like other bugs can be fixed separately. All right, so, and we actually did that in 2 hours, surprisingly, right? So we did that in 2 hours. That's actually pretty cool. I didn't expect that it's going to be that easy, right? So it's pretty straightforward, and yeah. So, and it's not even that much code. It's not even that much code. So it's actually, you could have actually included that in the Crossterm in the first place, to be fair, right? Even though Crossterm trying to be, we're low-level library, we're not supposed to be concerned with this kind of stuff. It's not that much code, right? We can even try to see how much code is that, right? So, so where is my diff? Where is my diff implement virtual for the templates? So okay, first of all, you need to have the cell, right? So an implementation and stuff like that, and then the buffer, right? And that is it basically, right? So first of all, the buffer, okay, and all of that computes the patch to apply to the terminal and stuff like that, right? So you have 80 lines of code just for the buffer implementation, just for the virtual DOM implementation. Right, and then you have the application of the patch, right? So the application of the diff, and that is around, 100 lines of code, Right, the feature that is only for the high-level libraries. 100 lines of code, like, I mean, come on. You could have just fucking added that, but Rust developers. All right, I guess that's it for the day. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you all on the next recreational programming session with Mr. Azuzin. I love you all. Mwah.